Hi, so welcome. We're going to move into one of the more traditional forms of operations management topics, which is bottlenecks and capacity constraints. So, what we're talking about when we're talking about bottlenecks in the terms of service operations is just like how the word is set, right? When you have a bottle, and I'm going to draw a bottle here. Sorry, it's kind of like a brandy bottle, I guess. This part here, right? That's considered a bottleneck. Um, and what a bottleneck refers to is literally this, right? But the reason why a bottleneck, the neck of the bottle actually exists, is it's to constrain the flow of whatever liquid is in here, right? Because if I didn't have this neck with a smaller diameter, than this, then all the liquid can pour out of the bottle really, really quickly. So by putting a bottleneck onto the bottle, I constrict the flow of the liquid out. So we can think of the bottleneck as the constriction point of flow. In this case, from a bottle, it's the flow of the liquid, right? And the bottleneck is constricting the flow of the liquid. Now, when we talk about services, the thought of a bottleneck is exactly the same, right? So in Shouldice, right, the process of Shouldice is when a patient comes in, they go through some sort of check-in service, right? They check in with the nurses and they do some administrative stuff, I think from the case, they check their pee, they check their blood, they check their weight. So all of that kind of check-in stuff. So they go through a check-in process, right? They unpack, and then the next day they go for surgery, right? And then after surgery, they have a hospital stay, right? And after their hospital stay, they leave. So we can think of this as the customer flow, a very basic version of the service blueprint, right? A very simplified version of the service blueprint. Now, the idea is the customer is flowing through these steps until they leave, right? So we need to find out what the constriction point is, what the bottleneck point of the flow is. Is there a point where our service ability constrains the amount, the number of customers who can go through the system? Okay, so in order to do that, we kind of need to determine the capacity, how much capacity to provide service do we as Shouldice have in each one of these steps. So when we want to determine capacity, it's a little bit more important to now go into the individual steps of service. So here, for example, as part of the check-in process, right, we have some administration, right, like checking insurance, payment, name and contact information, stuff like that, right? So some administrative stuff, and then they weigh, let's say, they weigh, they check the pee, they check the blood, right? Of each one of these steps. Now, from the case, each one of these takes relatively short amount of time, right? And there are plenty of nurses. So I'm going to go ahead and say, based on the information inside the case, that we essentially have infinite capacity here. So infinite capacity, right? So we have an infinite ability to service patients because this time is very small. So I'm going to say time is short. Time is short, right? It's like less than 10 minutes. This one is less than 10 minutes. This one is less than 10 minutes. And this one is less than 10 minutes, right? And they're all relatively quick steps. So because the time amount is so short, the inverse of time, so if it's short amount of time to take care of the guest, presumably we'll have more and more capacity to service the guest. Now, let's talk about surgery. Here, let's start thinking about the steps of surgery or the components that allow us to perform the surgery. From the service provider standpoint, let's think about what are the possible constraints to Shouldice being able to provide as many surgeries as possible within any given day. And I would argue that we have two. We have the doctors are a constraint, and then the number of operating rooms is going to be a constraint to our surgery. Okay. And now let's think about surgery in terms of number of surgeries that we can do, surgeries in a week. Okay. And because a week, the case doesn't really set up information in terms of a week, let's go ahead and say that this number is going to be number of surgeries per day times 7 days a week, realizing that this is currently up for debate, right? They only do surgeries during weekdays. They don't do it on weekends. But let's say that we're going to try that this will be a variable for now. Let's just say number of operating days per week. Okay. And that way we can kind of think about our capacity in terms of number of surgeries that we can do per day. And then we can just multiply it by the number of surgery days per week to get number of surgeries that we can maximally perform in any given week. Okay, so now let's think about on the doctors. We'll pose our question like this. At the most, at the maximum, okay, how many surgeries can our doctors perform per day? All other things being equal. This part at the end is very important because this part throws in the assumption that we're going to assume that the rest of the process, like all the other constraints, none of them exist. We are going to assume that doctors are the constraint, like the number of surgeries that our doctors can theoretically perform in any given day. So all other things being equal, so we're not going to pay attention to any of the other variables. We're just going to assume that the doctors are the constraint, are going to be the bottleneck. Similarly with the OR, right? We can write exactly the same thing. At the most, how many surgeries can be performed in our ORs per day, all other things being equal. Okay, so by this statement, what we're saying is all other things being equal, how many surgeries can we perform in our OR? Meaning we're going to assume that the OR is the constraint. Nothing else is the constraint. So we're going to assume that we have an infinite number of doctors, right? We're going to assume we have an infinite amount of resource except for the number of ORs. Okay, so we need to think about what the capacity is if the number of doctors or the number of surgeries our doctors can perform is the constraint, and we need to think about what the capacity is in terms of the number of surgeries we can accommodate inside our operating room if the operating rooms were the constraint. Okay, so again, that's the question that we're going to be posing to ourselves. We need to think about what the capacity is, how much throughput, how much flow can we get out of our doctors, how much flow of customers can we get out of our operating rooms. Okay. And then similarly on the hospital stay side, since, our patients are staying for more than one day, we kind of can't think of the hospital stay in terms of like a single day, right? Like what happens within a day. It's easiest to think about hospital stays within a week. So number of patient stays per week. Okay. And that's going to be, we're going to assume that the number of rooms, I'm going to say actually number of beds, okay, is going to be the constraint. So we need to find what is this capacity, right? How many patients can we have staying in any given week? And we're going to assume that the number of hospital beds is going to be our constraint. So there are a couple of things for us to calculate here. Is in order to find out what the maximum amount of customer flow is, we have to find out what is the constraint within these steps, right? What step is constraining the flow of patients from check-in to leaving? The check-in process is very fast, so we're going to assume that we have infinite capacity there. On the surgery side, we're saying that maybe the number of surgeries that our doctors can perform is the capacity constraint, is constraining the flow of patients. Or maybe it's the number of operating rooms that's constraining the number of, patients that we can perform surgeries on in any given day or week. Or maybe it's the number of beds that our patients have to stay in while they're recuperating that's constraining the number of patients that can go through the system. So now the question for us is, which of these, the number of beds, how many surgeries the doctors perform, or how many surgeries our operating room can accommodate, which one of these three pink things is the bottleneck? Which of these three things throughputs or flows the fewest number of patients in any given week? And that's what we're going to look into next in our Excel model.